Let's say, children, now, what is the next sum trying to say? This particular sum says, figure is given to you. In the figure, two circles intersect at points M and N. So two circles are intersecting at points M and N. Secants through M and N intersect. Secants through M and N intersect the circles at point RS, RS and PQ respectively. So the first secant intersecting the first circle at R, second at S, second at S. Second secant intersecting the first circle at P and second one at Q respectively. Prove that SQ parallel to RP. We intend to prove SQ parallel to RP. Now, children, keep this in mind. Henceforth, or even earlier also, you must have seen in many sums. Earlier also, that whatever I need to go for to prove is what I always show it by a dotted line. So here also, I'm going to show via dotted line. I intend to prove RP. Mind you, this is not given. This is to prove RP parallel to SQ. This is what we need to prove. Right, children? This is what we need to prove. Earlier also I have told you skeletal method. Now also I shall say skeletal method. I always prefer, my children, now I'm not going to give you the entire answer in skeletal way. No, I have to give you. Now I have to give you answer completely. It was only in the theorems where I said that I'll be going with skeletal way. But here also, in many sums is what I will give you skeletal answer for you to understand, for you to remember, and then write accordingly. Right? So whenever I'm giving you skeletal answer, that doesn't mean that in sums I will give you only skeletal. I shall give you both. Then why am I giving you skeletal? So that you can understand the sum very easily. Right? Let's proceed. So what is the thing I'm supposed to do is, I need to go for join Mn. That's what the construction will be. Join Mn. So if you want, you can write down that as construction, or in your first statement of your proof is what you can write down, join Mn. If you want, you can write under construction. Under construction, join segment Mn. Now children, before I proceed further, I have said this earlier also, and I shall say now also, that given is what you people have to write down. What I'm writing is proof, to prove, and proof part. If at all there is construction, I shall write down that also. But given part is what you people have to write down. I'm not writing anywhere given part. Let's start, but let's first start understanding skeletally. Right? According to me, you are free to pick up any one of the circle. Pick up any one of the circle. I should not say that pick up only this circle or pick up this circle. Pick up any one circle. So if you say, sir, we pick up smaller circle, fine. If you want, you can pick up larger circle also. So there is no exactly that which circle am I supposed to pick up. You are supposed to pick up any circle. So say I'm picking up the smaller circle. Quadrilateral RPNM within the smaller circle. What is quadrilateral RPNM? It's a cyclic quadrilateral by definition. All the 4 points lies on the vertices of circle. So what shall I say? What shall I say if it is a cyclic quadrilateral? Can I say opposite angles are supplementary? So it is 1, 2. So what is my first step in the skeletal solution? Angle 1 plus angle 2 is 180. In quadrilateral RPNM, angle 1 plus angle 2 is 180. Why? Opposite angles of cyclic quadrilateral are supplementary. Now, since you have picked up first smaller circle, within that a cyclic quadrilateral, now it's the turn to pick up the larger circle, and within that the cyclic quadrilateral. So can I say now for larger circle MNQS? For larger circle MNQS is also cyclic quadrilateral by definition. Is angle 2 an exterior angle for this cyclic quadrilateral? What was the exterior angle property for cyclic quadrilateral? Exterior angle is equal to angle opposite to its adjacent interior angle. So it is angle 2 congruent to angle 3. Exterior angle is equal to angle is congruent to angle opposite to its adjacent interior angle. So shall I say angle 2 is equal to angle 3? Equation number 2. Skeletal mind you. First for smaller circle 1 plus 2. Then for larger circle 2 congruent to 3. Now what can I say from equations 1 and 2? What can I say from equations 1 and 2? 1 plus 2 is 180, but 2 is already congruent to 3. So can I have every right to say 1 plus 3 instead of 2? Can I say 3? 1 plus 3 is 180. Now check children, what is 1 and 3 forming? 1 and 3 forms interior angle. Many have answered. Many must have answered. 1 plus 3 forms interior angle. For which two lines? For RP and SQ. And what is a transversal? RS as a transversal. 1 plus 3, we got it as 180. What are they forming? Interior angles. For which two lines? RP and SQ. What is a transversal? RS as a transversal. Therefore, by interior angle test, what can I say? RP parallel to SQ. This is what my skeletal solution is. This is what my skeletal solution is, children. I want you to remember the skeletal solution. Remember in the sense, understand via skeletal solution. Now, this is there in front of you. Let's write down our actual solution. Keeping this in mind, we shall. So this is skeletal, and now what are we going to do in our language? Fill up with tendons, ligaments, muscles, organs to get a complete organ body, right? Let's start. So my proof starts now. Now those who felt that, sir, before starting I'll say, sir, you picked up smaller circle. Had I picked up larger one first, I would have applied opposite angle here and I would have applied exterior angle here. Meaning is the same, right? Let's start. So we shall say for smaller circle, I'm just using symbols. You are not supposed to. Please don't use it. Let me not. For smaller circle, RPNM, quadrilateral, RPMN is a cyclic quadrilateral. Now why? The reason is what you shall say by definition. By definition. Right? You did not say that all the points lying. Since it's a cyclic quadrilateral, therefore, what was our skeletal first line? 1 plus 2. So what am I going to say? PRM plus MNP is 180. Equation 1. Opposite angles of cyclic quadrilateral are supplementary. Opposite angles of cyclic quadrilateral are supplementary. So I'm done with my first part. And in order to finish off my first part, can you see how much statements and reasons is what you have given? How many statements and reasons? Next, with this, I shall now proceed with larger circle. For larger circle, quadrilateral MNQS. Quadrilateral MNQS is a cyclic quadrilateral. Again, I shall say by definition. Now, this is a short form of definition. Children, I will write down shortcuts. Please, you don't write down. You'll lose marks. No shortcuts, please. MNQS is also a cyclic quadrilateral by definition. Can I say, therefore, angle 2 congruent to angle 3. So, what is angle 2? Angle MNP congruent to angle MSQ. MSQ, equation number 2. You can write down the entire theorem. I feel by exterior angle property for cyclic quadrilateral should work out very fine for you. By exterior angle property for cyclic quadrilateral. For cyclic quadrilateral. This is absolutely fine. So what can I say? From 1 and 2. From 1 and 2. MNP is congruent to MSQ. So can I say as it is PRM plus instead of MNP, can I say MSQ? PRM plus instead of MNP, can I say MSQ is 180? Still, we are not done. Those who feel that we are done, no, still we are not done. Because when I say I want PR and SQ, I have to go and take the entire angle. I shall not say only PRM. As of now it is PRM, right? But I shall not say PRM. I have to say PRS. That is PRS. And only MSQ will not do. I have to say RSQ. RSQ. There are many who might be saying, sir, angle is the same. Absolutely. But we have to mention the collinearity R dash M dash S. For a simple reason, why we are doing this particular step. Let me highlight and let me say this is an important one. Let me say this is an important one. For a simple reason, children. See, ultimately it is for RP and SQ we are supposed to go with. So I cannot restrict myself only to MRP or MSQ. I have to go beyond and connect them. So these are the connectors, mind you. So PRS plus RSQ is equals to 180. And reason is what I have to write down. Same angles with different names. Better reason will be R dash M dash S. What is this, sir? What is this? This is termed as collinearity. What is this? This is termed as collinearity. R dash M dash S. R dash M dash S collinearity. Now you have to say, but what are these two angles forming? But angle PRS and angle QSR, that is RSQ, forms what type of angles? But angle PRS and angle RSQ forms interior angles. They form interior angles. For which lines? For lines what? RP and SQ. RP and SQ. And what as a transversal? And RS as a transversal. And RS as transversal. Therefore, by interior angle test, by interior angle test, I shall say RP segment SQ. I shall use their language. Segment SQ parallel to segment SQ parallel to segment RP. Segment SQ parallel to segment RP. Now I want you people to look at my skeletal solution and my main solution. Skeletal solution 1, 2, 3 and the fourth step is the answer. But if I go with my main solution, now I want you people to correlate that I have done nothing but I have taken skeletal solution, elaborated it with all the statements and reason, and I have my entire answer. This is what we say reinvent learning. This is what we say, children. Refresh concepts, we reinvent learning. We change the method of learning. We take it in a very simple way, right? I hope you have understood this. Kindly go through, quite simple.